We have previously restored a few IBM PS1 and PS2 systems on this channel, but IBM also had a cheaper offering at the time to be able to compete with the clones, at least according to Wikipedia. I had a quick look at the specs, and this machine actually seems more similar to the Aptiva than the PS1 or the PS2. In this video we are going to restore and explore the IBM PS ValuePoint. We are of course also going to do some upgrades and find out how fast it will go. Before we turn things on, I think it's wise to have a look inside. Let's start with the matching CRT display. It has a very square design, unlike the other three IBMs. The stand comes off by pushing on these two tabs. Instead of the really hard to get tabs on the PS1 and PS2 display, this display seems to have regular screws, so no special tools required. There are two screws underneath the display and two screws at the top. And the usual disclaimer applies. Please don't poke around inside CRT displays. They may contain high voltages even with the cord unplugged. Okay, there is a small splash of soot inside the case, but this is looking pretty good, at least outside of the shield here. This display hasn't been turned on for years. Actually, I'm not sure if I ever tested it, but it's a good habit to always discharge. So far the design of this display actually looks more like the later G series. By the way, this display has a Hitachi tube, made in Japan, so probably good stuff. There are quite a few screws to get that shield off. Okay, let's see what we will find inside. Yeah, that's not bad. That's not bad at all. That is actually pretty clean. There is a tiny amount of soot, but not much. So I'd call that a lucky score. I did a visual inspection. There are no refuzz, no bulging caps, and not really any dust. So I'd say this display is safe to turn on. Overall, this IBM is quite clean, and the diskette drive has gone mustard yellow. To release the front panel, I think it's like the Aptiva. You need to push on two tabs underneath the front cover, and then you can slide the lid off. This chassis looks identical to the IBM PS1, but the motherboard is definitely different, and the power supply is identical to the PS1 too. It's really dusty inside here, and the original hard drive is still in the case. That's always a nice bonus, at least if it works. I see something interesting here. We'll get closer in a moment, but check out that socket and the VLB slot, just like in the Aptiva. I'm gonna have to double check, but I don't think this motherboard is identical to the Aptiva. Yeah, I'm pretty sure this is a different motherboard. This is, by the way, a MagnaTech, manufactured in week 22 in 1993. I had to replace two of the caps in my IBM PS1 power supply, so we're gonna have a look inside here before we turn this machine on. Holy cow, that is an interesting power switch. It has a large heat shrink tube, and then it's completely filled with resin. I guess it makes it a bit safer than power switches on most AT power supplies. A couple of screws at the back. We should be able to pull that power supply out. Unfortunately, it's put together with rivets, but we need to have a look inside. The hard drive is held in place with one screw here on the side and two screws at the front. We are of course going to install a CD-ROM drive in this machine. So let's remove these thingies and pull that hard drive out. In here we have a 244 meg Maxtor drive with IBM part numbers, so probably the original drive. That mustard yellow diskette drive is held in place with two screws underneath. Before we remove the bracket with the diskette drive, let's remove this card here. Unfortunately, it's just a network card. It would have been nicer with a rare sound card. And now we can remove this screw here, so we can remove this bracket here with the drive installed. I really like my IBM PS1. And seeing so many similar parts, I kind of like this machine too, without knowing if it's any good yet. Next we can pull that riser card off. This board is really dusty. Not sure if it shows up on camera. Oh, and aside from those screws, the motherboard is also held in place with 2 plastic tabs. Let's see if we're lucky or if they break. I think we're lucky. Quick correction. This power supply is actually not identical to the power supply in the PS1, because this power supply doesn't have soft power on. The disclaimer applies to the power supply too, of course. There are a few caps inside here that may contain high voltages, even with the cord unplugged. Now let's get these rivets off. Now let's take a peek inside and see if everything is okay. Apparently it's stuck in this zip tie here. Okay, a bit dusty inside here, so it needs some cleaning. Yeah, aside from that soft power switch, it looks identical inside here. At least if my memory serves me right. There are no refus and no bulging caps inside here, so we only need to blow that dust out with some compressed air. But we also need to make sure to get those rivets out before we reassemble this power supply. If you take one of these apart, count the rivets and make sure you get all of them out. If you leave one of the rivets floating around inside, it will short something. Also check this connector here for the fan. It's really crappy in these power supplies. In the PS1 it actually came off and fried one of these resistors here. Okay, everything cleaned up. I did some research, but there wasn't much to be had. This board has an 86C805 graphics chip. I don't know if it's hooked up to the ISA bus or the VL bus yet, but we'll try to find out in a minute. It has 1 meg of VRAM and it's upgradable to 2 megs with these sockets here. I don't have one of these modules, but 1 meg is enough for now. On the other side of the board, we have a cache slot here. Unfortunately, it's an IBM special. There are modules available with 256K of write-back cache. I checked eBay, of course, but there weren't any for sale at the moment. So, unfortunately, we're stuck with level 1 cache only. Unless someone makes a project and makes a clone of one of those cache modules. Chipset is VLSI VL82C306. And perhaps the most interesting bit is this socket here. These are pretty unusual. It's obviously an overdrive socket. From what I could read online, it will take a 487SX, or P23T66, or P24T83. Unfortunately, I don't have any of those, but the 487SX is actually a 486 ODP in disguise. And I've got one of those, so we can definitely go faster, but let's do a test first, before we do any upgrades. We need to replace that coin cell before we do the test. I guess we should have a look inside the drive too. Oh, that's not too bad. Oh, that's quite unusual. There is no dust inside this drive. Oh no. It has surface mount caps and they are leaking. That doesn't look too good at all. Well, we might as well find out if I have these caps in my stash. They shouldn't be too hard to replace. Now I think we can fold this PCB back. Yep, so we've got... Oh, there's only 2 caps on this board. So this guy here is 47 micro 16 volts. I'm sure I got one of these. This one here is a 22 micro 6 volts. Let me check. Unfortunately I didn't have any, but I placed an order right away. The corrosion is pretty bad on this board. This guy here just came right off when I tried to measure it. So I'll put this drive aside and we'll repair it in a future video when the caps have arrived. Okay, all the bits and pieces are cleaned up and hooked up to the motherboard, except for the original diskette drive. But I got a spare drive here. So we're ready for a test. Let's see if this board works. That is a pretty loud drive. Okay, we're getting graphics. IBM PS ValuePoints. Okay, we've got a couple of errors. Pointing device, bad CMOS, diskette drive, date and time. Well, that's odd. That diskette drive should be okay. Well, I don't like using flat panels with vintage machines, but for the sake of the video, let's use one anyways. Okay, so we've got a 486DX, we've got the graphics chip I mentioned, and a 245 meg hard drive, 8 megs of RAM, 8K internal cache disabled, and I can't enable it. That is odd. Not great. And here we have the diskette drive. Okay, that's good enough for me. I decided to replace that noisy hard drive with a slightly less noisy drive. And apparently the system boots just fine. This drive also has some benchmarks. So let's run SpeedSys and find out how slow this board is. Okay, we've got a 486DX running at 33 MHz. And we're getting an incredibly slow score at 12.36. Now let's see if that cache actually is disabled. No, it's not, so the BIOS is lying. We've got 8K of cache here. Okay, let's see if it will run Doom. Well, it sort of does. It's a bit slow, but it does run. Okay, that's great, so that means we can get a score for comparison. This is an absolute slideshow. Definitely not playable. I'm gonna go and grab some coffee and skip ahead here. Okay, it eventually finished at 5171 real ticks. So that gives us 14.4 FPS. So this is officially the slowest 486 I have at the moment. Let's see if we can improve this. Okay, let's pull that DX out of that funky looking socket and try out an ODP100. Let's turn the machine on. Okay, it posts. Okay, and it boots. So let's run Doom again. Yeah, this is actually quite a bit faster. Yeah, this is totally playable. That made a huge difference. We got a score of 2600 real ticks. That is quite an improvement. That's about twice the speed. Yeah, that is almost exactly twice the speed. So from 14.4, we now have 28.7 FPS. That was an awesome upgrade. Let's have a look in SpeedSys. We're getting a score of 38.37. And we've got a 16K level 1 cache available. So one big advantage with this system compared to the PS1 is that the BIOS doesn't disable the cache. Even though it was marked as disabled in BIOS, we actually have the full 16K of cache running. That makes me wonder if it will take a regular ODPR. Let's find out. Okay, it posts. And in the BIOS it only reports 8K of cache. And it boots. So let's have a look in SpeedSys. By the way, I'm not sure if I mentioned earlier, but this is the Type 1 board. There is also a slightly different Type 2 board for these machines. Yeah, sure enough, we've got full 16K of cache. So that's just a glitch in the BIOS. We're getting exactly the same score as for the ODP. So no need for a fancy ODP for this board. Regular cheap ODPR will do just fine, and will in fact double the speed of your board. The next thing we want to find out is whether that graphics chip is hooked up to the ISA bus or the local bus. I disabled the onboard graphics with J17 and installed a Cirrus Logic GD5422. It's not a perfect comparison, but it should be close enough to tell us whether that chip is VLB or ISA. Okay, let's run Doom and see what we get. Yeah, I think it's a bit slower. That is actually a good sign. We're getting 22 FPS, so I think that onboard graphics chip is hooked up to the VLB bus. But let's confirm this. Let's try this board with the slowest VLB card I have. This is a Cirrus Logic GD5428. Let's run some Doom and compare the results. Yeah, I think this is faster than with the ISA card. We're getting a score of 27.6 FPS. That is almost the same score as we got with the onboard graphics chip. So not a perfect comparison, but this definitely tells us that the onboard graphics is hooked up to the VLB bus. So pretty good board so far. But how about an AM5X86? Okay, fingers crossed. Well, it does post. And it boots. Okay, let's check SpeedSys. Okay, it recognizes AM486. And it's running at 100 MHz. So we need to change the multiplier and see if it will go faster than the DX4. Luckily, there is a jumper for it on the socket blaster. So let's give this a try. I removed the VLB card and changed jumper J17, since the onboard graphics are actually slightly faster. Now let's see what will show up in SpeedSys. Okay, so now we have a clock multiplier of 4. So we're now running at 133 MHz. And we're getting a higher score of 42. Now let's see what kind of scores we will get in Doom. Okay, we're getting 29.5 FPS. That was actually not much faster than with the DX4. That's a bit odd. I was expecting a lot more. But that's what we've got. Well, if we're gonna go any faster, we need to increase that clock speed. So I decided to do some tracing on the board. And here's our pin for the clock on 486. And that pin is going to this via here. And then it rather mysteriously just disappears and can't be found on any chip. So I had a look on all the chips, but I couldn't find any obvious clock chip. So then I took a look on this side of the board. And here's our mysterious via that seems to go nowhere. And this side of the board is just completely filled with resistors and caps. But I managed to trace it to this tiny little resistor here. And apparently this is a 47 ohm resistor. So that's why it wouldn't beep on any of the chips on the other side of the board. So knowing this, I started to look for 47 ohms. And wouldn't you know, we've got 47 ohms from the clock pin on the 486 to this chip here. Unfortunately, this IBM branded AOYUE chip doesn't seem to have a datasheet online. So that's a bummer. I can't say for sure, but it's a pretty good guess that this AOYUE chip here is generating our clock. But without the datasheet, we can't hack that damn chip. Or perhaps we can. Let me do some thinking and testing, and I'll get back to this board. I cleaned the chassis and all the other parts, so everything is nice and shiny. Unfortunately, this board is very picky with RAM. I was only able to add 2 more megs. These 2 RAMs are IBM branded, but one of the sticks that was already on the board isn't. I went through a whole stack of RAM sticks, but none of my other sims would work on this board, except for one more stick. But that thing was 80 nanoseconds, so the performance dropped 2 FPS. Needless to say, I skipped it. There's not much point in having an AM5X86 on this board, until we have figured out how to speed this board up. So I'm gonna go with an ODPR for now. It's only 1 FPS slower than an AM5X86 at this speed, at least on this board. To install a CD-ROM drive in the machine, we have to put it upside down. And then put the hard drive cradle on top and mount it from this side. Really odd solution, just like in the PS1. But the Aptiva had a better solution. Same thing with the diskette drive. Really unusual, since the motherboard already has VLB graphics. There's no point in wasting an expensive VLB card on this build. Well, I'm not sure, but I think this machine was the cheapest offering from IBM. So I'm gonna go with an ESS card for this build. These are cheap, but they sound really good. The only thing left to do now is to put the lid back on. Well, with the CD-ROM drive installed, it looks like it has yellowed slightly. Not just the diskette drive. But then again, the lid is painted, and paint doesn't yellow, does it? So maybe it's my CD-ROM drive that is pale. It does look a bit yellow compared to the other 2 IBMs. I'll give it a quick retro bright and see if I can get it to a similar color. I don't see the point in comparing it to the PS2, because they don't seem to have anything in common. Compared to the PS1, it's much easier to upgrade. We had to hack the motherboard twice and use a hacked BIOS, but we also reached a respectable 38.6 FPS. And we're not even done with that project. I'm pretty sure it still has a few more FPS in it. I know exactly what we're going to try out next. The Aptiva is unfortunately stuck at 32.2 FPS until someone hacks the BIOS, because it won't take an AM5x86. So which one is your favorite so far? I will of course revisit this project. If you're watching this in the future, there will be a link to the next attempt on the screen shortly. If you're watching this fresh, hit the bell icon below and set it to all. And now is a good time to watch the PS1 hacks and overclocking videos. I will end this video by saying thank you to my patrons. I appreciate your support. If you want to support me too, consider becoming a patron. Patrons get ad-free early access. If you want to help me make more videos like this, like and leave a comment. Thank you for watching, and I'll see you next week.